Good morning, everybody. Welcome to our first webinar. My name is John from a company called Performance Lighting. Been in the industry for 35 years, 30 years in lighting. Today we're going to talk about the differences between lumens and watts. Brief overview about the history of lighting in terms of the types of lighting, so incandescent, fluorescent, discharge in comparison to LED. And the importance of looking at lumens instead of in conjunction with watts and not alone. Thank you very much. Let's start the webinar. So moving on to more current technology, which is obviously LED, light emitting diode, that stands for. Probably been around a lot longer than you think. They're first discovered in the early 1900s, but not for lighting purposes. They originally was used for fibre optic telecommunications and not in a white LED, which is what we use now. They were often coloured, so they'd potentially be used in traffic lights. So we're one of the first things to use LED because it's a coloured LED. The first white LEDs were produced by a company called Nichia, and that was in the mid-90s, approximately 1996. But we still really wasn't used commercially then. It's probably only since the early 2000s that we've sort of started to see LEDs to become used commercially in lighting. LEDs need a compatible LED driver to control and operate them. Quite a bit more specific than the old fluorescent, because the fluorescent was very generic. A 5-foot 58 watt was a 5-foot 58 watt, and there was no differences other than colour temperature. We'll talk temperature a little bit later. But it was very much, you had a 5-foot 58 watt tube, you had a 5-foot 58 watt ballast. LEDs are very different. They're quite bespoke, and whilst there is some generalizations, but they require specific milliamp ratings and forward voltages, which is what the driver supplies to power the LED. In terms of since the sort of early 2000s, LED technology has moved on, but there's not revolutionary, just improvements in efficiency and life, really. So you're now getting much higher lumens per watt than you did back in the early 2000s. Obviously, I'm old and I've been around a while, but I remember, back in early 2000s when LEDs first came out, we were looking at around 70, 80 lumens per watt, and we'll talk about that. And this is one of the major things we're going to talk about today. But now we're up, some LEDs are claiming up to 170, 180 lumens. I've even seen claims of 200 lumens per watt. So, twice the power for the same amount of wattage. And obviously the life has increased. Again, LED life a little bit different to fluorescent and traditional. Traditional was very rigid, but with LED, it does massively vary on the quality and how they're powered and how they run. Some LED is sort of as low as 20,000, and then some people and some of the higher end, better specification LED are offering 100,000 hour life output, so massively increased over the old technology. A slightly new feature, and we won't really touch on it today, in relation to colour temperature, is tunable white, which means you can actually change the colour temperature. It's one LED, and it can go through the colour temperature normally from 2,700 to 6,000. So that's available, and it's fairly new technology, but we could always speak about that on a further webinar in the future. So I guess that's a little bit of background about fluorescent and LED. Hopefully that's been quite insightful. What we're really going to talk about, and what the title of the webinar today is, understanding watts and lumens and what the differences are. So I guess, for want of a bit of a pun, what is a watt? So a watt is the SI unit of power. So it's the amount of energy that something needs to make it work. So lots of things have the wattage on them. So not just lighting. So you look at a microwave oven, you'll look at even a TV, or you'll look at a heater, or lots of things that you'll see in your everyday life will have the wattage on, because that's the amount of energy and power it's using to make it operate, basically. Electricity is measured, and due to current energy costs, most importantly paid for per kilowatt hour. So that's what that means is how many kilowatts, which is 1,000 watts, are used in the hour. And electricity costs have obviously increased very dramatically over the last few years, as everybody knows. Probably doubled and trebled. So 50p, maybe 60p, 70p per kilowatt hour these days and upwards, which I suppose when you think about it, 1,000 watts costs you 70p per hour to run. Doesn't sound a lot, but if your overall lighting is, if you're using 30 kilowatts or 100 kilowatts of lighting in some big installations and more, lighting suddenly becomes a big expense. And one of the sort of looking at research, some commercial buildings, lighting typically makes up around 20 to 50% of their overall electricity costs. Even more so in some of the, big office block type environments where there's multiple floors, open plan with lots of lighting, and their main power usage will be lighting, aircon, and then sockets, PCs, those sort of things. So I guess upgrading the lighting to high efficiency LED can reduce electricity costs, reduce the carbon footprint, and just can lead to significant energy saving costs. So reducing costs for the overall business, to be fair. So that's basically what a watt is. Now, what a lumen is, it's very different. So the lumen is actually the amount of luminous flux, so the total amount of visible light that the eye sees, and that's measured in lumens. People often get confused between lumens and watts, and they think the higher the wattage, the brighter it is, but that's not necessarily the case these days, especially with LED. So a lumen's constant, so regardless of whichever technology you're using, whether it be LED, whether it be fluorescent, whether it be metal halide, whether it be a light bulb at home, if it's 500 lumens, it's 500 lumens. It doesn't matter what source that's coming from. What does make a difference is the amount of energy, also the number of watts that's needed to produce that 500 lumens. So, talking about the old stuff, if we look at a 60 watt old incandescent light bulb like you used to have at home, that used to produce around 500 lumens. Whereas nowadays, with the highest performing LEDs, if you were to think about using 60 watt LED power, you can get in excess of 10,000 lumens from that. So you're getting 20 times more light for the same amount of energy. A good example from home, if you're using that 60 watt light bulb, historically, you'll now be replacing that with an LED light bulb that's probably only 7-8 watts. So you can just so easily see if you've got 30 light bulbs across your house and you were using 30 times 60 watts, you were using 1,800 watts, and suddenly now you're using 30 times 6 watts, you're only using 180 watts. So you're saving 90% of your energy just by swapping to LED. So that's kind of what a lumen is. It's the intensity and the amount of light that comes out of, and that's how that's measured. So lumens versus watts. This is what's, I guess, the crux of the webinar is, and what it's important. So we've established what a watt is, I like that pun, and what a lumen is. So now we can kind of discuss why comparing lumens versus watts is really important. So just talking again about the older technology, a 5-foot fluorescent tube, T8, and was always 58 watts, circa 5,000 lumens. Again, there is lamp degradation, which I briefly touched on, but straight out of the box, 58 watts, 5,000 lumens. With control gear losses, it probably cost you in energy 62, 63 watts to actually power that 5-foot 58 watt tube. Whereas now LED is so much more diverse. A 5-foot LED luminaire can have a lumen output of something around 2,000 to 3,000, up to 15 to 20,000 lumens. Not looking at the wattage right now, but 5 foot in fluorescent was very, very rigid, whereas 5 foot in LED, it can be so massively varied. That's why it's important to talk about A, the luminaire design, but also B, the lumen output that you're looking for rather than the wattage. So a good example of that, as I mentioned previously, that 60 watt lamp offers 500 lumens, but 60 watt of LED can offer 10,500 lumens. So that's why it's really important to think about the efficacy of the product. So again, because there is different efficacies, which is efficiencies of LED, it's important to look at the lumen output versus the wattage, and that's where you can see even more energy saving. As a lighting manufacturer, we'll quite often get asked for, a good example is a 200 watt LED high bay, and people won't ask what the lumen output is, they just want a 200 watt high bay. Some 200 watt LED high bays are circa 20,000 lumens, so 100 lumens per watt. But then we could have a 150 watt LED high bay that is 24,000 lumens, so it's actually brighter than the 200 watt and using less energy. So that's about the efficacy or efficiency of the LED. When certainly for most sort of end clients are looking to upgrade or install new LED, they're looking for the best energy saving. So that requires a high efficacy, high lumens per watt value. So the better the efficacy, the better and quicker, the bigger the savings, the quicker the payback period. So on retrofit projects, people often quote payback, so payback period. So what they can do is they can calculate what the current energy consumption of their existing lighting is. So we have a little energy saving tool calculator, so we can work out, put in what their existing lighting, so the amount of watts they're using right now, times by the average number of hours it's on per day, giving you an annual cost of the electricity, plus timesing that by what their individual electricity costs them. And then we can work out what the annual cost of the lighting is. And then we can look at if we were going to upgrade that to LED. So a really good example on a 600 by 600 recessed modular fitting, which you'll have seen in offices quite often with a shiny louver in there. That was traditionally 4 by 18 watts. So that's 72 watts. And with a bit of energy losses through the control gear, probably 75, 76 watts of power that was using. Whereas now we would swap that out for a 30 watt LED panel. Again, so that's probably using around 31. There's very little losses with LED. So 31 watts of power, maybe 32 watts of power. So 50% energy saving. So if that's the only light fitting that you had in your building and your energy was costing you for your lighting £50,000 a year, an example, and you swap to LED, you're suddenly going to half that energy cost, £25,000. So what then can be worked out is by changing to new LED upgraded lighting, it shows how much money you're going to save. And then what we can then work out is what's called the payback period. So if it's going to cost you £75,000 to install that and buy that and install that new LED lighting, but you're going to save £25,000 a year on your energy. So within 3 years' time, that new LED lighting has paid for itself. And then beyond that, because it'll have a 5-year minimum warranty, those energy savings are pure savings. So not only have you got a nicer looking upgraded lighting system, you're also saving money as well. And obviously with the cost of energy, that's really, really important. Just sort of thinking about the first generation of LED, as I mentioned earlier. So you might get, might have been 80, 90 lumens per watt early, just picking on LED panels because it's easy to talk about. The early generation LED panels would have maybe have been around 45 watts, 3,600 lumens to replace the 4 by 18 watt fluorescent, whereas our current generation of LED panel runs at 30 watts, 3,600 lumens. So even somebody who's got LED panels in, or LED installed could still see some big energy savings if we swapped out a 45 watt first generation or early generation LED panel to our the newest generation of LED panel. They could see a 30%, another 30% reduction in their lighting costs. So I think people sometimes think, oh, we've got LED, so we don't need to have an upgrade. But it depends how old that LED is. So as you can see from what waffled on out there, there's lots and lots of potential in energy saving, but it is really important to think about actually the lumen output rather than just thinking about what wattage you want to buy. The other thing to think about when we talk about LED and fluorescent, but certainly more so in LED, is the colour temperature. So when choosing the LED product, you need to think about what colour temperature you want for your particular setting. So LED colour temperature, regardless of whether it's LED or fluorescent, is measured in Kelvin. And that sort of ranges right from 1,800 Kelvin, which is almost a red colour, all the way to 12,000, which is almost like a really, really blue-white colour. A naked eye can differentiate these, although not sort of specifically really closely, but you would be able to easily recognise the difference between 3000K, which a lot of people use at home. That's classed as warm white. And the reason people use that at home because it has a warming effect and it just makes it feel nice and cosy in your living room or wherever it may be. And then in the kitchen, somebody might have 4000K because that's a little bit colder, not colder, but cooler and a little bit crisper. So your eye sees that and it looks cleaner in comparison to the sort of warmer yellow 3000K. And then depending on, again, the environment, we can go up to 6,000, 6,500K, which is a almost blue, quite clinical white light. Quite often, maybe dentists or hospitals or doctors' surgeries may use something a little bit cooler because it gives you the effect of clinical, bright, quite stark almost. So colour temperature is really, really important, and it's important to think about the colour temperature you need when you're asking for specifying the product that you want to buy. That has a big impact. Strangely, and we won't talk about it too much today, but your eyes, the human eye is an amazing thing, and it can see millions of colours, it can see colour temperature, but it can also trick you as well, because if I could set up two rooms, both exactly the same lux level, which is a measurement of light, so they could both be 500 lux, but if we had them at two different colour temperatures, we could have them in warm white, we could have them in daylight, and I could ask you to walk into both rooms, and you would say the one in daylight was definitely brighter, but I could show you on a light meter that actually the light is exactly the same level, so it's just that your eye perceives, because it's cooler and it perceives it to be brighter. So colour temperature and selecting colour temperature is really important. Some products in LED are single colour, so you need to specify the colour temperature. Other products, some of which we have in our range, are what's called CCT selectable. So CCT stands for a bit of a mouthful, correlated colour temperature. So our leader baton is a good example as a CCT switch, so you can change your colour temperature from 3,000 or 4,000 or 6,000K. So if it's good, if you're not sure what colour temperature you or your customer wants, we can supply one fitting, and then if they say, oh, that's a little bit too cold, that colour temperature, at 6,000K, you could change it to 4,000. Or if they've got an application where they'd like it to look a little bit warmer, they can change it from 4,000 to 3,000. So colour selectable is a good feature. To be fair, it's not available in all products, and it's not suitable for all products either. But it is a good feature, and from a wholesaler point of view, when they're stocking a product, it makes it much easier for them because they only have to stock one product to cover all three colour temperatures. So when we think about looking at what LED we want to choose, it's important to make sure we choose the right colour temperature. So if we talk about LED lifetime now and warranty, I know we've mentioned obviously the number of hours, just another sort of little thing to touch on. So when you're choosing an LED product, you should obviously consider the warranty because, again, talking about efficiency and payback and recycling and the circular economy and being green, if you choose something with a better warranty, hopefully that means it's going to last longer and therefore less likely to need to be changed and recycled and disposed of. There's many companies offering different warranties, from 1 year to 7 years. As a standard, we offer 5-year warranty on all of our products. We expect them to last longer than that, but I think you've just got, in our opinion, we just have to be sensible about warranty. And also, I think practically as well, if something's been installed 7 years, the likelihood is the building probably needs an upgrade and a refresh and people are due for a change. So I'd expect our LED product to last way beyond the 5 years. But will it look quite as nice because it's not shiny and new? Would people want to have a refresh and a change? Probably so. So the warranty's there to protect against failures, but I think sometimes we get a bit blinkered by the amount of warranty. It's there as a safety net, really, just in case there was ever a problem and somebody needs, and failures happen in life, there's nothing we can do about that. It's just how we deal with that. A little bit more from a technical point of view. So quite often on a LED product that they should, or you can ask for the L and B values. So which these mean the L is the percentage of the light that an LED produces compared to its initial value after a set number of hours. So the closer to 100%, the better. You'd never achieve 100% because you're always going to lose some life over time. But and then B, so this is the acceptable failure rate of L. So in an ideal world, the very best, and this is not achievable, would be L100, so 100% of the light output compared to its initial hours, and B, zero failure rate of the L rating. But ideally, you need to strike a compromise because obviously the higher the L and B rating, the better performing, the better quality LED. But obviously there's, like everything in life, there's a cost implication to quality versus cost. So in an ideal world, you want something that sort of strikes a happy medium. So L80, B20, L70, B20 is good. L90, B10 is fantastic. So just to try and put some context around that, L80 B10 at 50,000 hours means that after 50,000 hours of installing, you'd expect to still be getting 80% of the original light output. So if the product was 10,000 lumens, you'd expect after 50,000 hours, you'd still be getting 8,000 lumens out of that product. And the 10, which is the B rating, 10% of the LEDs would fail to reach that 80% light output. So what that's giving is some tolerance. So while you're saying that you're expecting to give 8,000 lumens out of the 10,000 at 50,000 hours, it's okay that 10% of those aren't going to achieve that. If your L and B rating was down at L50, B50, that wouldn't be very good because what you're saying there is you're expecting 50% of the products 50% of the original light output. So that's going to look very dim and dark. And out of that, 50% of those aren't going to even achieve that. So that would be a bad example of an L and B rating. I know that's been very quick and lots of information to take in, but I hope you found that really useful. I don't know if anybody's got any questions that they would like to ask. There is a bit of a question chat at the end, and we've recorded this webinar. So we'll be able to send a recording out for people who haven't been able to log on. And obviously, we're always available on email if anybody's got any questions or, would like any more information. Hopefully, everybody's found it interesting and informative. This is the first one that we've done. We're going to do more in the future. Next one potentially about website optimization, SEO optimization, which not directly linked to lighting, but if you've got, if you work in a business or you own a business, then it's important. These sort of things are important to drive website traffic to your website. So we're going to try and make it a little bit diverse and not just talk about lighting. But yeah, there is other ones planned for lighting. We talk about dimming and controls. We talk about emergency lighting on future webinars. So I hope everybody's found that useful. I hope we've all found it informative. And all I can say is thank you very much for joining. Thank you very much for watching. If you're watching it on a pre-recorded version, it's Friday, so I hope you all have a lovely weekend. Stay safe and keep well. Thank you.